Why are we not doing PGS in France?
Well, I definitely won't try and answer that one myself. Perhaps someone in the audience?
No. That's not allowed in France.
Okay, simple answer. Is that likely to change? If it's not permitted now, do you see any likelihood of it happening here? René?
No.
What do you think?
Not in.
Why it's not allowed? It's not eugenicism, right?
Yes, you're right.
The actual sort of laws governing PGS and PGD vary quite widely within Europe. So, for example, Germany, Austria, Switzerland have traditionally been very conservative in their application of this kind of technology, probably because of fears of eugenics from their recent history. We've also seen interesting things in Italy. Italy used to be perhaps the most wide open country in terms of what you could do in terms of embryo research. And then there was a huge swing in the opposite direction. It became incredibly restrictive. But now it's starting to open up again, especially as some patients actually took their government to the European Court demanding access to PGD. So it's interesting that in Europe it's not homogeneous. It's quite different in different countries.
Concerning the fact that you see a correlation with the higher amount of mtDNA and the failure in implantation, this may be due to a problem in heteroplasmy. That one mechanism to solve the problem of the defective mitochondrial DNA is to increase the amount. And what is the chance to solve the problem by PGS in terms of mitochondrial DNA content?
Yeah, it's an interesting one. So that was my favorite theory as well, that actually the increased levels of mitochondria might represent a compensatory mechanism because the mitochondria were not working properly. Perhaps they contain mitochondrial DNA mutations. We have done some whole sort of genome sequencing of the mitochondria from these embryos, and actually we haven't really seen any evidence of increased levels of heteroplasmy or mutations within them. So we don't really understand what it means. There are a couple of big gaps in our work at the moment, and I'd be happy if anyone could fill them. Firstly, we haven't proven that there are more mitochondria. We've proven there's more mitochondrial DNA, but as you know, it doesn't necessarily mean the same thing. The other thing is we haven't done any functional tests. So all these mitochondria, are they functional and these are very energetic embryos, or are they completely non-functional and it's more the compensatory kind of story that we were talking about? Of course, Henry Leese, years ago proposed the idea that very metabolically active embryos are actually the least viable. And so maybe we're seeing some kind of echo of that. I don't know. It'll be interesting to find out, though. As far as PGS, again, it's a selection tool, so it can identify these embryos for us. It can't fix them. Of course, another question is whether this finding has any implications for the whole mitochondrial transfer story. As you may be aware, there are companies, or a company, which is collecting mitochondria and injecting them into eggs to try and revitalize these eggs. Is having more mitochondria a good thing or a bad thing? If what we're seeing is compensatory, then maybe it's good to put in some new healthy mitochondria. If what we're seeing is that high metabolism is bad, then adding more mitochondria may even be detrimental. So I have no answer for that, but it's an interesting question.
So in order to still in line with our French bylaws, how about polar body screening comparing with embryo, implantation embryo screening?
Yeah, it's a good question, and of course that's been the traditional mode for places like Germany. When they haven't been able to test the embryo, they've fallen back and tested the polar bodies extruded during meiosis to learn about the chromosomes of the egg. Of course, that's where most of the aneuploidies are coming from, so it makes sense to do that. Well, the methods work well. The next generation sequencing, or the array CGH, does a good job of showing you the abnormalities in polar bodies. The only reservations I have about that are that, first of all, you're not learning anything, of course, about the paternal contribution. which is smaller, much smaller, but not zero. And the other thing is there have been one or two rather worrying publications suggesting that the polar bodies are not entirely predictive of the eventual status of the embryo. And that may just be a technical thing. You have to take the polar body at just the right moment because it remains attached to the egg by a thin cytoplasmic bridge. And if you don't take it at the right time, you may actually lose chromosomes within that bridge and think they've been lost from the polar body when actually they should have been in there. So there's a few difficulties there, I think. Much better if it could be done at the blastocyst stage.
In your practice, you perform, you remove blastocyst, trophectoderm cells on day 5, early in the morning. You perform your analysis, genetic analysis, and you have the result in the late afternoon?
Right, so I should say that mine is just a genetics lab. I don't have an IVF lab. We work with about 30 different IVF clinics, both in the UK and as far away as South Africa and the Middle East. They send the samples to us and we do the tests. So it depends. Increasingly what we're seeing is blastocyst biopsy, cryopreservation of the embryo, and so in that case we usually release the results 2 or 3 days later because there's no great rush. But we still have a significant number of clinics that want to do a fresh transfer. So for them, yes, it's a 24-hour result. So if they're very close to us, we may get the cells the same day as the biopsy and give a result the following day. If they're a little bit further, then they'll get the results the day after that. So we have different methodologies. If the embryos are being frozen, we always use next generation sequencing because it's the cheapest method. We can offer the lowest possible price to the patient for doing the test. If they need a very rapid test, we'll use something else like quantitative PCR, which can count the copy number of all the chromosomes within about 3 or 4 hours. So that way you could even biopsy embryos quite late in the day of day 5 and still have a result either that day or at the very beginning of the next morning.